Welcome to our home chemistry lab!
Today in our experiment, we're going to do a simple yet exciting experiment, the titration of an eggshell powder. The experiment shows us how acids and bases interact in a process called neutralization.
And our young guest is
Ahmed!
our young scientists.
Hi, I'm ready to learn something cool. But first, we have to apply the PPE.
So since we're at home right now, and we're not in a science lab, this experiment is going to be home safe. So you're going to find these types of materials that we're about to say at home, and you can also do this experiment. So the first thing you'll need is crushed eggshells. The second thing you'll need is white vinegar. The third thing you'll need is baking soda. And the fourth thing you'll need is a pH indicator. Because since we have the pH indicator right here, then we're going to use that. But if you guys don't have pH indicator, then you could use red cabbage juice as your pH indicator.
Also, we have to use clear glass jars, like for example, like the ones that we have here. We have to have a teaspoon. We have actual one that's actually meant for chemists, and we have to have safety gloves and goggles. That's the ones that we're using right now in this chemistry actually.
Wow, you can do this at home?
Yup, that's right.
Exactly. So basically, you don't even need a science lab for this. You don't need anything basically. You can literally do this at home, in a kitchen, في المطبخ, whatever you want.
Actually?
Yes, bro, exactly.
Now take notes.
That's cool.
Okay, let's start with the experiment. So we have to have around like quarter of a cup of eggshell powder. So and we have to put it in a clear glass. And actually, eggshell powder contains calcium carbonate. It's actually very useful because it's the main component in this chemical reaction.
So step 2, you have to pour 1/4 cup of white vinegar into a jar. Stir the mixture and tell us what you see, Ahmed.
Let's begin.
Let's put 1/4 cup.
It's around like 59 milligrams of vinegar.
Just like that. So what do you see, Ahmed? What do you see, Ahmed?
It's bubbling a lot.
Oh, great observation, Ahmed. You know that there's carbon dioxide gas being released as calcium carbonate reacts with vinegar? The chemical reaction for is actually up top right now on the screen.
Actually?
Yeah.
Go check it out right here.
Now let's neutralize any leftover vinegar with our baking soda solution. Slowly add the solution drop by drop and stir it.
So that's baking soda, guys. Ahmed, you seen this? Look at the chemical reaction. What's gonna happen?
And keep on stirring. Keep on stirring, Ahmed. I want you to see what's happening.
Oh!
It's expanding. You see that?
It's expanding.
Oh my God! See that, guys? You see this, guys? Look how sick that is.
Now, let's try to put the pH indicator that we have, like we mentioned before. Muhammad, can you show it, Muhammad?
Yeah.
That's okay? It's the pH indicator right here, guys. And we're going to try to see what color it turns up. Remember, you can put cabbage juice into it also. So we're going to put some droplets into it. And whatever color it turns, we're going to mix it up together. We're going to see. Whatever color it turns, we're going to know if it's acidic or not. We're going to show you a table right now with it on the screen.
Bit by bit, and that shows us that it's going up and trying to neutralize at the end. So now let's figure out how much calcium carbonate reacted. In real experiments, we'd use calculations, but here is a simplified version because it's at home. The amount of bubbling tells us how much gas is produced. More bubbles means more calcium carbonate reacted.
So the eggshells are gone because they're turning into something new?
Exactly. So basically, calcium carbonate turns into calcium acetate, water, and carbon dioxide. That's how the reaction works. It's getting neutralized. So you see, even the color is turning purple alive with us this second.
That's actually sick.
But wait, why is this useful in real life? It's not like we're ever gonna use this.
Great question.
Well, there's neutralizing reactions everywhere in life. Like everywhere you think of, there's always going to be neutralizing reactions. Give me one example, Muhammad.
So using baking soda to treat heartburn. This is a great example because baking soda always treats heartburn.
Also, like balancing soil acidity, and for plants, for example, because for vegetation to grow, you have to have the acid to be in a perfect amount. What else? Cleaning up vinegar with also, like, for example, using the washroom, for example, when we're cleaning them up, we use vinegar to clean them up. Whenever we have the stove that we use at home, yes, there's always going to be a black stuff always accumulating on it. So we use that to clean everything off of it. It's vinegar is trying to clean and help us neutralize whatever dirty things, or just in general every acid.
In general, most of the time, every single day, you're gonna use neutralization in your life.
Wow, I'll tell my friends about this.
Exactly. Good job, man. So, Ahmed, like during these type of chemical reactions, you have to keep safety like number one priority. Can you give me something from your mind why it's important to be like safe even during real life, anything when dealing with chemicals in general?
I think it's because vinegar is an acid and baking soda can fizz a lot. So I think that's one of the reasons.
That's right, exactly.
Because of this scenario.
Because of this scenario. If we were to look back, like in general, let's say if we look back at Miss Sidra even, remember our old chemistry teacher back in the day that taught us? Yeah. One of the questions that she was asking us during her test was talking the different symbols that are on different products for chemicals.
Exactly. There's some symbols that will help us tell whether we're supposed to be safe and what things we have to take precaution in. Okay, so for example, there's an acidic logo that is found on acidic substances. Now you might see, and you have to wear gloves and safety things. What is it called?
What is it called?
It's called skull and crossbones. It's up there.
Up there.
Thank you for joining us. And remember, chemistry is all around you.
Thank you for teaching me. I'm ready to try some more experiments in the next chapter of this video.
Oh, it's purple!
It's actually purple.
Yeah.
You see, it's actually working, man.
Wow, you can do this at home?
Yes,
Exactly.
That's
That's what we're
right.
talking about. So basically, you don't even need a. You don't.
Someone.
Okay, don't talk. I'm gonna talk.
But why is this useful in real life? It's not like we're ever gonna use this.
Great question. So now let's figure out how much calcium carbonate was needed. Actually, restart.
Remember that we were asked in one of the final parts, part 8, was asking us to give us one of the symbols for acidic stuff. Do you know, Muhammad, what it was called?
I'm supposed to say that, you flipping nuts. I don't know. You're the one who knows.